In the space of science and epic privileged insights, the subject of what existed in advance to the huge impact has blended conversations and intrigued characters for quite a while. This Goliath request doesn't just test how we could disentangle the universe. It challenges the authentic farthest imperatives of human data. Imagine remaining at the edge of presence, exploring the huge shadowing and taking into account what lay there before our universe was imagined. The occasion of the enormous detonation denoted the beginning of history, space, and all that we know. In any event, there was a second sooner in advance. Could there sooner or later have been a condition of nothingness, a calm already, before the gaudy gathering started? And if this is legitimate, was it, or perhaps there was something considerably more upsetting that existed as of now before time itself? As we bob deeper into this request, science takes us on a journey beyond the universe's beginning stage, into examinations that challenge our mindfulness. Physicist Brian Cox, known for his commitment to the miracles of the universe, recommends that something dumbfounding might have existed before the Titanic blast. He moves us to rethink our thinking of this present reality and presence. In this evaluation, we'll dismantle the science, the speculation, and the astounding insider secrets that might sort out what existed before all that. We'll examine contemplations like godly improvement, quantum changes, dim energy, and even multiverses. The reactions we've uncovered might just stifle you, yet they could similarly open new understandings of our circumstance in the universe. Plan to hop deep into a world beyond imagination's science, where the dull still winds around the shadows, leaving specialists dazed and at times even steamed. We ought to explore what existed before the huge explosion and why these hypotheses challenge all that we expected we knew to see the value in. What could have existed beforehand the enormous detonation? We first need to inspect what the huge explosion truly was. The enormous detonation, as scientists describe it, refers to the moment when the universe ended up being staggeringly hot and thick, growing rapidly to set off the improvement of all matter, energy, and boundless forces. When we look toward the night sky, we see proof of this hot beginning, with systems spreading out all over from a starting point. In any case, for what reason did this happen? Or was there a time before this thick, hot start? As shown by the theory of massive expansion, there was without a doubt a before, and it was off by far to void or peaceful. Enormous advancement proposes that, before the huge explosion, the universe was in a state that was cold, unfilled, and free, essentially like a giant vacuum. Anyway, the vacuum wasn't completely unfilled. It contained a huge amount of energy that controlled the expedient development of space itself. This development, called expansion, happened so rapidly that it essentially settled the cause of all that would continue in a piece of the resulting space. It widened at extreme rates until the development toned down, and the energy changed into issue particles and the forces we see as the huge explosion. Yet what was the nature of this energy? Why did it, out of nowhere, foster the universe, and why did it stop? Specialists believe that this boundless expansion made patches of the universe, each experiencing its own huge explosion. Imagine a fabric expanding ceaselessly, with minuscule air pockets forming to a great extent, each air pocket representing a universe, including our own. This thought, called the inflationary multiverse, proposes that there are possibly vast large bangs and a boundless number of universes. Our own is only one of many. This colossal, mind-twisting reality challenges how we could decipher the very universe itself and leaves us with a question. What else is out there? The prospect of nothingness before the huge explosion is speculative, not genuine, at any rate per our continuous seeing. Paying little regard to whether you kill all energy, particles, and radiation from the universe, it would still not be truly void. Our universe is topped off with dim matter, dim energy, quantum fields, and various forces that weave a certain woven craft of something, even in its most vacant form. Paying little attention to whether we imagine stripping away these forces, leaving a dead space, the universe would still create new kinds of energy. This reality alone is baffling to specialists, as it suggests that true nothingness might be unfathomable within our limitless appreciation. Space itself has properties, rules, and constants that hold it back from being completely unfilled. Imagine creating a region with literally nothing in it. No particles, no radiation, and no energy, besides quantum fields and critical constants. these would still exist, suggesting that this nothingness has properties. For instance, there's an eccentricity called Z-point energy, which tends to the most inconceivable energy condition of quantum fields. In this state, particles can still promptly appear and dissipate, making a dreadful resonance of improvement even in what should be empty space. This challenges our idea of a veritable void and suggests that, yes, even before the enormous detonation, there was something that scientists are at present beginning to grasp. Potentially, one of the most amazing theories in current cosmology is the chance of godlike development. If expansion could make our universe exist, it's possible it could proceed forever. Brian Cox describes an extraordinarily gigantic inflationary multiverse, where universes are unfathomably made and keep broadening. Imagine each huge detonation as a flash lighting another universe, while expansion happens in various locales, making innumerable different universes. This cycle could, in principle, happen perpetually. This idea of colossal universes conceiving others leads to an enrapturing thought of a fractal universe, where each new universe may, in fact, make its own huge explosion. Every universe exists as an alternate, independent space, unaffected by the others, considering the rapid advancement of space. For researchers, this hypothesis is both energizing and upsetting, as it proposes an endless multiverse with no definitive beginning or end. Imagine our universe being just a tiny fragment in a vast, incalculable plan, continuously developing and consistently making new universes. And imagine, what if that's the very thing the disturbing truth is? There is no before or after, but rather an eternal pattern of universes forming and decaying. How we could decipher nothingness changes when we consider quantum field theory. As demonstrated by this theory, the universe isn't just a mix of issue floating in space. Perhaps it's a complicated association of energy handles that fill the universe, interfacing to make all that we notice. These fields resemble subtle seas, with particles acting as waves or disturbances. Even when fields are at their most minimal energy level, known as the vacuum state, they are still dynamic. Particles can appear and evaporate in these fields quickly, acquiring energy before returning it. This idiosyncrasy results in virtual particles, substances that immediately exist and then vanish, leaving just a weak memory of their presence. The possibility of virtual particles challenges the chance of a veritable void. Imagine an unfilled universe where all matter, radiation, and energy are taken out. Would you have, truth be told, nothing? As per quantum field hypothesis, you wouldn't. Even in a vacuum, fields would stay dynamic in some cases, making transient particles. This reliable improvement in the thing ought to not be anything, which recommends that the universe doesn't see our concept of opportunity. The fields and powers persist, filling the universe with a mysterious energy that forestalls outright nothingness. This understanding brings up a dazzling issue. If fields make particles and particles make matter, might the actual universe at any point have ascended from this nothingness loaded up with quantum fields? Dark energy is an odd power that, by and by, drives the accelerated improvement of our universe. Anyway, did dark energy exist before the Big Bang? According to specific perspectives, the way that dark energy exists today is an extra of an energy field from before our universe's development. The properties of dark energy appear to recommend a Goliath stowed-away power that might have existed in some structure before the Big Bang. A few theories propose that dark energy, in a much stronger state, could have controlled the inflationary stage, causing quick extension. The presence of dark energy suggests that, whether our universe were drained of all matter and radiation, this power would keep on developing the surface of spacetime. This thought prompts an upsetting request. If dark energy was available before the Big Bang, could it sooner or later have shaped the circumstances that prompted the introduction of our universe? Could dark energy be the tranquil designer of expansion, or even the genuine start of our universe? As we investigate this chance, we face the capability of dark energy not only as a power shaping our universe, but as a key that could open the secrets of the multiverse itself. Another speculation that offers an option in contrast to the Big Bang as the definitive beginning is cyclic cosmology, which suggests that the universe goes through immense examples of birth, death, and restoration. In this model, the Big Bang is definitely not a one-time occasion, but perhaps part of a godlike cycle where universes develop, break down, and then recuperate in another cycle. This speculation suggests that our universe might have been re-established from the remainders of a past universe. The course of compression and advancement in a cyclic example would truly mean that there was never a genuine start, but instead a timeless series of universes emerging, creating, and recharging themselves over and over. Cyclic cosmology raises critical requests now, as it suggests that time itself might be rehashing rather than direct. If this speculation is correct, it could infer that what existed before the Big Bang was simply another type of the universe, one that fell exclusively to bring forth our current universe. For researchers, this speculation offers a rich answer to the subject of outrageous origins, proposing that there is no conspicuous beginning. The universe has always existed in some form, transcending our considerations of time and presence. Gravitational waves are another fascinating idea that could reveal insight into what existed before the Big Bang. These waves, found in 2015, are swells in spacetime brought about by monstrous, grandiose occasions. A few specialists believe that gravitational waves could convey confirmation of events that originate before the Big Bang. These waves could, in principle, offer a brief look at what the universe resembled before it became noticeable to us, pushing how we might interpret the start of the universe much further. The possibility of the pre-Big Bang universe is certainly one of the most mind-twisting thoughts in current physics. There are, however, many ideas as there are stars overhead. What might have existed before the Big Bang? Might there at some point have been something we simply can't as yet notice or gauge? The more researchers look, the more inquiries they pose. Anyway, one thing is clear. This quest for the obscure will continue to energize interest and investigation for years into the future. As how we might interpret the universe expands, the topic of what existed before the Big Bang remains one of the most significant mysteries in science. Speculations like the inflationary multiverse, dark energy, quantum field changes, and cyclic cosmology give tantalizing insights, but no conclusive answers have arisen. Every hypothesis raises additional questions, testing the limits of our insight and imagination. The more we get familiar with, the more we understand that the nature of our universe, its origins, its construction, and its ultimate destiny might be undeniably more complicated and strange than we ever imagined. For some, that there might be no evident beginning to the universe is a troublesome idea to acknowledge. The traditional perspective on the Big Bang as the solitary beginning point of everything is deeply imbued in how we might interpret spacetime and existence. Yet as scientists push the limits of physics, it's becoming increasingly evident that the true story of the universe is much more complicated. Ideas like the multiverse, in which endless universes exist with their own rules and laws of physics, suggest that our universe is only one of many that might have emerged from a complex, interconnected vast cycle. As we dig further into quantum mechanics, we are faced with the possibility that the actual texture of spacetime is not a static setting but a dynamic, ever-changing substance. The quantum vacuum, which we once considered empty space, is now recognized to be abounding with virtual particles, variations, and fields that might have had an impact in the production of our universe. These particles pop in and out of existence in a way that opposes our old-fashioned understanding of reality, suggesting that even in the most profound voids of space, there is no obvious vacancy, just potential for new states of matter and energy. This leads to another captivating possibility: that the universe we notice today might have been born from a quantum fluctuation. In this view, the whole universe might have risen from an imperceptibly small point of highly concentrated energy, with a Big Bang serving as the moment this energy was released. This thought fits within the framework of quantum mechanics, where uncertainty and fluctuation are not just normal, but central to the behavior of particles and fields. Such a situation raises significant questions about causality and the nature of time itself. If the universe could emerge from nothing, then how would we define what preceded the Big Bang? The role of dark matter and dark energy in these speculative hypotheses couldn't possibly be more significant. These baffling powers, which make up most of the universe's mass and energy content, remain poorly understood. Dark energy, specifically, is a force driving the accelerated expansion of the universe, yet its origin and properties remain elusive. Some researchers speculate that dark energy could have been a vital ingredient in the rapid expansion of the early universe, influencing the outcome of the Big Bang and potentially playing a role in the creation of the multiverse. Another intriguing possibility is that the universe is in a state of unending resurrection, one in which time itself is recurrent. In this scenario, each Big Bang may be the result of the collapse of. The idea of a cyclic universe challenges our conventional view of time as linear, suggesting that the universe might have no evident start or end. This view aligns with ancient philosophical ideas, where the universe is seen as timeless, with no definitive beginning or end, but a continuous process of change. As we continue to explore the nature of reality, one thing is sure. The questions surrounding the origin of the universe and what existed before the Big Bang will continue to fuel scientific investigation and philosophical inquiry. Each discovery brings us closer to understanding the fundamental workings of the universe, but also opens up new mysteries and challenges. As our tools for observing the universe evolve, from powerful telescopes to advanced particle accelerators, we may one day uncover answers to these age-old questions. But for now, we are left with the remarkable realization that we are still just beginning to uncover the astronomical riddle. Maybe, in the end, the true answer to the question of what preceded the Big Bang is something beyond our current understanding, a mystery so vast and profound that it may take humanity hundreds of years, or centuries, to fully grasp. Yet the journey to uncover this mystery is a testament to the boundless curiosity and ingenuity of the human spirit, truly striving to understand the universe and our place within it.